Hi, good evening. Today I am going to explain my project topic, which is about design and control of compact and low-cost solar microinverter system. This is my project paper, and my supervisor is Dr. Ashraf Ali Khan, and my subject code is ENGI9858. Here is the content of my all the project: abstract introduction, block diagram, system design and topology analysis, circuit diagram, simulation, PV characteristic, conclusion and references, which is all topic I include in my project. The abstract of my project is the recent years have seen a rise in the use of renewable energy sources as the result of the rising demand for various energy sources because of its durability and energy saving features. Residential sites will always benefit from the rise of renewable energy because it is more efficient and cost effective, especially given the variety of technology available, including inverters, panel, batteries, and so on. Various waveform are example of the inverters. There is a different kind of inverters which we can already seen in the market. Two of the rumors numbers of limitless sources that are being employed extensively to produce energy are the sun and wind. There are the energy gathered from the various source needs to be storage in the batteries and later uses after then we can use that. Standalone system is not connected to the grid. A compact low cost microinverter for uses in houses was modeled and controlled after the analysis of the household system. A small sustainability less expensive inverter will be utilized to change the DC, which is the case is normally supplied from the battery into AC after the project is complete. So this is the abstract of my project. And now this is the introduction of my project. One of the various components of the PV system is a microinverter. It is goal to change DC into AC. A single solar panel is connected to a single inverter in this system, and the output from the several microinverter is aggregated and sent to the grid. The major advantage that microinverters have brought forward is that the inverter module and string mismatch will not take place. Not only that, but it also enables the panel to operate the maximum potential with higher reliability and efficiency, as even when a panel fails to perform or is the damage to entire system will not come to the half. Every microinverter operates with the single panel at a time. Buck and boost converter are necessary to maintain the DC voltage level for the proper operation of the inverter in addition to the range of devices that will be needed. Therefore, cable become one of the main system issue for the compact and affordable design consideration of little aspect like a number and size of the power electronics parts. So this is the introduction. Is the basically mostly the change DC into AC by using a different topologies in the PV system. So that is the main things which we are performing this the project. And this is the block diagram of my project. So firstly is the sun. By sun rays it's generate the solar energy, and solar energy to electrical energy it's converted by the solar panel, and then it's using the charge controller by controlling the all the power supply, and then battery banks is using for the storage the electrical energy, and then it's interlinked with the inverter and optional generator. So if there is the energy generated from the generator, then it will be directly linked with the inverter, and also battery bank is connected with the inverter. So whenever that power supply is needed, then it's convert into AC to DC and DC to AC. So it can be used easily used in the residential purpose. So inverter is work for the to provide the power supply to the residential home. And this is the system design and topology analysis. So here you can see different solar panel is connected to each other, so they can generate the more power, and it is connect with the DC breaker. So it can is a work as a, like a switch, and then inverter is the DC to AC, and it's also connected with the AC load. So AC power can be used as per the requirement, and it's also linked with the battery bank, which is 24-volt DC. So it can be store the energy, and whenever it's required, then we can reuse this energy. So here is the different items, and which is the specifications for the using that's the thing. So there is the PV voltage around 444 44.6 VDC, and PV current is 15.66 ampere. Battery voltage is 24 volt, and battery capacity is at 250. While battery backup is for remaining 2 days, and maximum output power is 1 kilowatts. So this is the system design and topology analysis. And now this is the circuit diagram of the my project, which is again the PV panel, and it's linked with the 50% duty cycles tank inductor. It's connected with the blocking capacitor, and again it's joined with some diodes and inductor capacitor, as well as its work as a buck inverter, and its unfolders EMI filter, which connected with the AC line. So finally, it's connected with the current control and pulse width modulations. So it's joined with the input voltage control loop. So you can see is a DC transformer boost current, and the some sine wave also in the system. So it's the circuit diagram of the my system, and this is the circuit diagram of the MATLAB simulations which I use in the MATLAB circuit for the output waveform. In this system, I use many electrical components like scope, three level bridge, boost converter control, PV array, and choke. So you can see the circuit diagram which I already did in the MATLAB system. So this is the circuit diagram. Here is the simulation of the my system waveform. Is the voltage and current waveform. You can see it is in a sinusoidal form. So both is in a same phase current and voltage. So it's completely in a sine wave. So this is the solar PV characteristic, is the current versus voltage. Here I can see ISC is the maximum, while VOC is the significantly decrease with respect to time, and P max is the power maximum. So current versus voltage graph showing the power maximums and MPP points as well. This is the steady state analysis of the design system. Here is the different features used in the system to monitorize the different various things. Cost summary, cash flow, compare economics, electrical, renewable, punctuations, narada, and you can see the different quantities, values, and units. Like a batteries is a 4 quantity, string size is a 2 batteries, string in parallel is 2, bus voltage is 24 volt, and here is the different quantities like autonomy, storage, wear cost, nominal capacity, expected life, and you can see the stage of a charge, which is around 190, 100, and different things. So it's a stage of the charge is respective of the different months from January to December. So you can see all the things, and frequency is increased gradually. So it's the it is showing in the percentage in the system. And this is the conclusion of my topic, which is about data about about rural homes energy use is a glen from the previous year's electric bill. The planet technology is affordable and simple to implement. Every element employed in this research is easily accessible in the local market. The Homer simulation is run using current data on solar irradiance, temperature, and load at the chosen location. According to the results of the Homer simulations, the planned PV system is capable of powering the chosen rural home throughout the year without using the local utility grid. The plant system is generating 729 kilowatt per hour year to power and chosen home electric load and charge 41. So this is all the references which I use in my project. By referring this literature review, I can made my project and it's complete. Without this literature review, I can't do more things. Thank you so much.